Imagine a massive power outage plunging millions of people into darkness. Now imagine the entire electrical grid collapsing into chaos. It sounds like a dystopian nightmare, doesn't it? We'll uncover how these sophisticated systems monitor, detect, and react to electrical disturbances faster than the blink of an eye, preventing widespread blackouts and safeguarding our critical infrastructure. Before we begin, don't forget to subscribe so you'll be notified whenever we upload a new video. Let's get started. Stay tuned because by the end of this video, you'll understand why substation protection relaying systems are the true unsung heroes of the electrical industry. These sophisticated systems are responsible for detecting faults such as overcurrents, short circuits, and ground faults, and then taking the necessary steps to isolate the affected sections of the grid. Firstly, they ensure the reliability of the electrical grid by minimizing the impact of faults and outages. By quickly isolating faults, relaying systems reduce the duration and scope of power disruptions, ensuring that customers experience minimal downtime and service interruptions. Secondly, substation protection relaying systems play a vital role in protecting critical infrastructure. One common type is the overcurrent relay, which, as the name suggests, is designed to detect overcurrent conditions in the grid. As the name implies, distance relays determine the distance to a fault in the grid. Protective relays and other components should be regularly inspected, calibrated, and tested to ensure they operate accurately and respond promptly to faults. Traditional electromechanical relays have been replaced by more sophisticated electronic devices known as intelligent electronic devices or IEDs. Emerging trends and developments hold great promise for improving the efficiency, reliability, and adaptability of these systems. One notable trend is the increasing use of advanced algorithms and machine learning techniques in relaying systems. IEDs enable greater flexibility and adaptability in protection schemes, allowing operators to configure and modify relay settings remotely and efficiently. By continuously monitoring electrical parameters, detecting faults, and coordinating protective actions, these systems safeguard our modern way of life. Subscribe so you'll be notified whenever we upload a new video. And remember to turn on notifications so you never miss an upload. Thanks for watching. From overcurrent relays to distance relays, the various types of relaying systems play distinct roles in preventing widespread blackouts and protecting critical infrastructure. As technology advances, emerging trends such as machine learning, phasor measurement units, and intelligent electronic devices promise to further enhance the performance and adaptability of substation protection relaying systems. By embracing these advancements and investing in robust maintenance practices, electrical operators can ensure the continued effectiveness of these vital systems, safeguarding the electrical grid for generations to come. This, combined with substation automation, reduces the need for manual intervention and increases the overall efficiency of the electrical grid. Machine learning algorithms can analyze vast amounts of data, identify patterns, and make predictions, which can significantly enhance the performance of protective relays. By leveraging machine learning, relays can detect faults more accurately and respond faster, reducing the time it takes to isolate faults and minimize disruptions to power supply. IEDs offer several advantages over conventional relays, including improved accuracy, faster response times, and enhanced communication capabilities. PMs provide real-time information about the state of the power system, enabling more precise and effective relaying. The use of PMUs in conjunction with advanced algorithms and machine learning enhances fault detection, improves system stability analysis, and enables better coordination among relays. These devices utilize advanced microprocessors and digital signal processing techniques to perform complex calculations and make real-time decisions based on input signals from various sensors and measurements. IEDs can communicate with each other and other devices in the power system using standardized protocols such as IEC 61850. This enables them to exchange data, synchronize measurements, and coordinate protective actions. The communication capabilities of IEDs allow for the implementation of distributed control and protection schemes, enhancing the overall flexibility and reliability of the substation protection relaying system. This helps to build confidence in the system's ability to protect the grid and critical infrastructure in the event of a disturbance. Various testing methods and equipment are available to verify the functionality of different components, such as relays, circuit breakers, and transformers. These tests may involve simulating fault conditions to check the system's response time and accuracy. Additionally, specialized diagnostic tools are used to test the internal operations of the relays and other devices. Regular maintenance and testing not only ensure the effectiveness of the protection system, but also help to identify potential issues or weaknesses that can be addressed promptly. By investing in ongoing maintenance and testing, electrical operators can enhance the reliability, safety, and overall performance of their substation protection relaying systems. They measure the impedance of a line, and when a fault occurs within a specific distance, they signal the protective relays to activate. This helps in quickly isolating the affected section of the transmission line and minimizing the impact of the fault on the rest of the grid. Different types of distance relays utilize various measurement techniques to calculate the distance to a fault. Some common methods include impedance measurement, which calculates the impedance of the line and compares it to a predefined value. Reactance and MHO relays are widely used distance relaying methods that fall into this category. Reactance relays measure the inductive reactance of the line, while MHO relays consider both resistance and reactance to determine the fault distance. Additionally, time over reach relays, also known as torrent relays, measure the time it takes for the fault current to reach a specific level and then compare it to a predetermined time setting to determine the fault distance. When an overcurrent occurs, such as during a short circuit or overload, the current transformer sends a signal to the relay, which then triggers a circuit breaker to interrupt the flow of electricity. Another type of protective relay is the directional relay, which monitors the direction of power flow in the grid. This relay helps to prevent the flow of electricity in the wrong direction, ensuring that power flows through designated paths. It's particularly useful in interconnected power systems where multiple sources of electricity are present. Many industries and facilities rely on a continuous and stable power supply to function properly. For example, hospitals, data centers, and manufacturing plants need uninterrupted electricity to operate. By safeguarding the grid, relaying systems help to protect these critical facilities from the damaging effects of power outages. Furthermore, substation protection relaying systems enhance the safety of electrical equipment and personnel. Faults in the electrical grid can cause equipment failures, fires, and even electrocution if not addressed promptly. Relaying systems help to prevent such incidents by isolating faulty equipment and diverting current flow, ensuring the safety of both electrical assets and personnel working in the substation. By doing so, they help to maintain the stability and continuity of power supply while also protecting equipment and personnel from damage. At the heart of any substation protection relaying system, the protective relay itself. If the current exceeds a certain threshold, indicating an overcurrent condition, the current transformer sends a signal to the protective relay, which then activates the appropriate protective measures. Voltage transformers play a similar role in monitoring voltage levels. When the voltage drops below a safe range, signaling a potential undervoltage condition, the voltage transformer sends a signal to the protective relay, triggering actions to mitigate the issue. These specialized devices are designed to monitor electrical parameters and detect faults in the grid. Protective relays continuously analyze data from various sources, including current and voltage transformers. When a fault is detected, the relay initiates a series of actions to isolate the faulty section of the grid. But what if I told you there's an unsung hero working tirelessly behind the scenes to prevent such disasters? These disturbances can include overcurrent conditions, short circuits, ground faults, and other electrical anomalies. To fulfill this function, relaying systems continuously monitor various electrical parameters such as voltage, current, and frequency using specialized devices called protective relays. When a fault is detected, the relays activate specific actions to isolate the faulty section of the grid and restore normal power flow. These actions may involve tripping circuit breakers, opening switches, or initiating other protective measures. Welcome to the world of substation protection relaying systems, the silent sentinels that safeguard our modern way of life. In this video, we will explore the substation protection relaying system, delving into its crucial role in maintaining the stability and reliability of our electrical grids. Welcome to our channel, the place where future engineers come to get inspired. Substation protection relaying systems play a critical role in ensuring the reliable and safe operation of the electrical grid. The primary function of a substation protection relaying system is to safeguard the electrical grid against various disturbances that can disrupt the flow of electricity. The importance of substation protection relaying systems cannot be overstated. They are essential for several reasons. To better understand how substation protection relaying systems work, let's break down the process into smaller parts. One of the key components of a relaying system, the current transformer. Its job is to monitor the flow of current in the power system. Protective relays come in various types, each designed to detect specific faults or conditions in the power system. Distance relays are another essential component of substation protection relaying systems. To ensure the proper functioning and reliability of substation protection relaying systems, regular maintenance and testing are crucial. With the increasing complexity and interconnectedness of modern power systems, the demand for advanced relaying systems has grown significantly. As technology continues to evolve, the field of substation protection relaying systems is constantly advancing. Another exciting development in substation protection relaying systems is the integration of phasor measurement units, PMUs, which are devices that capture synchronized measurements of electrical quantities such as voltage and current. Moreover, substation automation and the use of intelligent electronic devices, IEDs, continue to drive advancements in relaying systems. In conclusion, substation protection relaying systems are the unsung heroes of the electrical grid, ensuring its stability, reliability, and safety. We hope you enjoyed this video. If you did, don't forget to give us a thumbs up and share it with your friends.
So now, a bit about me. My name is Mike L., and I am an experienced electrical engineer who has worn many hats, holding key roles in projects, engineering, planning, operations, asset management, maintenance, and field resources development. I design and pioneer engineering solutions to propel the utility and energy industry forward. My passion within the industry has also driven me to develop educational materials for the new generation of utility and energy professionals. The knowledge I teach is not only based on my own experience within the power utility industry, but also on knowledge gaps identified by other professionals in the field. Learning from me will provide you with the comprehensive, fundamental knowledge you need to kickstart your professional career in the utility industry. If you are interested in what I have to teach, check out my courses at Udemy and connect with me on LinkedIn, X, and Facebook. Don't forget to comment, like, and subscribe this video. Bye for now.